Hello everybody, my name is Dr. Arshad Afridi and today we will learn about machine learning. So let's start. What is machine learning? Machine learning is actually used to improve the performance of programs based on given data, previous results or experiences. The aim is to develop some methods to extract meaningful information from examples. Uh, these are the methods for creating computer programs by the analysis of data sets. So if we see that there is important thing there is data or data sets. So machine learning is actually learning some function or some pattern from the given data set. This is simple definition of machine learning. The aim is to finding out patterns in the data or solving problems using patterns in the data. Understanding machine learning with examples. For example, a robot can classify different patterns. So if we see that this robot actually classify different patterns from rectangle, triangle, square, triangle, and so this kind of pattern, this robot is used to classify these kind of patterns. Another example of understanding machine learning with example is like, for example, a robot can learn and tell about an apple. So for example, this is a robot which classify or which know about an apple. So let's see, this is an apple, and robot adjust different weights of the apple to learn more about that, or that do just disappear. So when another apple with green apple is shown to that robot, so it learned from a previous example that this is an apple. Another example, for example, uh, this is a neural network, an example of neural network which classify cat or learn cat. So when we show different picture of cat to this neural network, so it gives us that this is cat. So for example, when some ambiguous picture is shown to this this neural network, so then from the previous experience or result, it decided that this is a cat. There are a number of application of machine learning around. For example, voice recognition, face recognition, fingerprints, iris or DNA recognition, signature recognition. There are another area application research area of machine learning is web searching, document and information retrieval, or machine translation. So if we see, then there this picture show different voice recognition, biometric authentication, face recognition, and digital signature. And this image show the web searching. When we write a query, write some string or query, and then it is given to the internet or the Google. So it use some kind of IR system and which ranked documents, and based on that some corpus or a string or text is extracted from that, and the ranked document or the ranked pages are then ranked and shown to the user. There are another application of machine learning. For example, spam filter. You see, there are a spam folder available in each email. So when a spam email is received, then it is directly sent to this spam folder. So how it decides that this email is spam? So it actually read the email and found certain words, for example, some kind of lottery, some kind of money, or this type of word if available in email with the usual pattern, and that is being trained. So then that email is considered as spam email. And then there are some kind of recommender system, for example, to user which they want to see or buy a mobile phone. And then when a user one also see some kind of headphone, so the internet or the online shopping recommender system recommend the headphone to another user who have already seen the mobile phone. So this is actually kind of recommender system which recommend to the user based on their similar experience on the internet or on the user of that application. There is another example of machine learning is fraud detection. So for example, you use your credit card to buy to do some shopping, and that card is actually hacked by the middleman or the bad boys. Then your data is compromised, and that and then they can use that card for their own shopping. So this is also in the scope of machine learning. And then there is marketing, stock market prediction. So you predict the future value of a stock market, or cryptocurrency these days is very popular. So you see actually you predict based on the sequential data available, or the already price in that given range, and based on that available data, or some kind of sequential data analysis, and then it gives some predictive analytics on the available prices, and a user can take benefit from these prediction, and can decide wisely at the time of investment. Then there is another very famous example of AlphaGo, that is actually Google DeepMind project, where a computer has defeated the master of a game, Go. The master of the game was Lee Sedol. So actually, Google DeepMind trained the computer for itself by using deep reinforcement learning, and when the program is smart enough or trained enough, then it was exposed to play with the human expert, and the world has seen that the computer defeated the best player of game Go. There are some related discipline of machine learning, for example, artificial intelligence, data science, data mining, pattern recognition, intelligence systems. So data science actually the science of data analytics, visualization, predictive analytics, and it gives some information about the available data, and based on that you can decide different things based on the available data. Pattern recognition is actually finding pattern in different data sets or different available data. Data mining is actually extracting data or extracting information from the available data or the big data. Adaptive control is actually the adapting the control as the situation changes or as the environment changes. And then intelligent system, so intelligent system or robotic system which could be made as intelligent to make intelligent decision. There are related theory which is very important for machine learning, or which might help the reader, or the person who want to learn machine learning from, for example, probability and statistics. So there are certain probability and statistic theory which is very important. For example, conditional probability, Bayesian rule, independence, maximum likelihood, normal distribution, expectation, variance, covariance, and covariance matrix. And there is another related theory, that is linear algebra, which is very important while we calculate uh, different machine learning, or we learn different machine learning, how it works, how it's made. So there are different terms which need to be learned. For example, inverse matrix, eigenvalue, eigenvector, singular value decomposition. And then there are optimization technique which is really needed for machine learning to become expert. And for example, gradient descent, convex optimization, expectation maximization, quadratic programming. And then there are programming skill which is required: dynamic programming, divide and conquer, computational complexity theory. Types of machine learning problems. So classification is one type of machine learning, in which a set of label data is given. So your program should be smart enough that find the boundary between the labels. So, and then if a query is given, then the program would be smart enough to decide that it ranges in which class. So if we see that there are two classes, red and black, but the query is of different color, and then the program should be smart enough to decide that this query belongs to this class, or this is more near to this class. So classification is actually a learning concept which basically categorize a set of data into classes. So for example, single level classification based on shapes. So rectangular and circular shapes are classified based on the shape. So there are multiple applications of machine learning: speech recognition, face recognition, handwriting recognition, document classification. And then there is another example. For example, we have two different kind of circle or dot. So the program should be smart enough that it classify red from green. And the complexity increases from here to here, so that's why the shape is changes, the shape of the line is changes due to the complexity of the system. And then there is another example of classification in which different fruit is classified as an apple or not an apple. So for example, these four there are four different fruits, so which is decided based on their shape, their class. So if fruit is apple, so it is decided as an apple. If a fruit is not apple, then it is classified as a non-apple category of fruit. There is another example of machine learning which is regression. So regression is actually a set of x, y, when there is a x and y given, x-axis and y-axis is given. X is a vector and y is a real number. So your program should find the functional relation between x and y. If a query x is given, your program should answer y for x, y for x where x lies. So this is a example of a regression. So in regression we need a best fit to the available data. So this is an example of regression. Regression is a learning technique which is used to predict continuous values. So if we see in the previous slide, there was a data given on xy plane, and we need to find some best fit line for that. Or if a query is given, then it 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 is it could decide based on the available query that where it should lie. The ultimate goal of the regression algorithm is to plot a best fit line or curve between the data. So for example, this there are two types of person. One is doctor, and another group is nurse. So there is a best fit line needed which decide between the nurse and doctor, and a best fit is required for that. So there is a 3D model which actually a best fit line is required for blue and green dots. There is another example, and there is a bit complex example which classify a complex blue and green blue and red dots. Clustering, there is another example of machine learning called clustering. So actually it requires unlabeled data. So what is unlabeled data? There is no output available, and there is a bunch of data available, so we need to cluster that. The program should group the data and finding the hidden structure of data. So based on the hidden structure of data, the program should group the data. If a query is given, the program should determine the group in which the query belongs to. Clustering is the process of grouping similar entities. So if there is some kind of relation between the data or similarity, then it could be grouped together. The goal of this unsupervised machine learning technique is to find similarity in the data point and group similar data points together. So for example, there are a number of different balls. So the model sees some pattern in these balls, and based on that pattern they are grouped together. So one group, second group, and third group. And then there is a group based on color on xy plane, so that these are grouped based on the color. There is another machine learning type of machine learning problem is dimension reduction. The aim is to reduce the dimension so that it decreases the complexity of program, and it reduces the burden of a processing system. Dimension reduction is actually need a set of unlabeled data, and your program should reduce the dimension by minimizing the loss of information. The aim in dimension reduction is to minimize the loss of information. So first this dimension is changed to this dimension, and then it is changes to single axis or removing all other axes. So if we could see, more complex information is just transfer into a small line. So but the important thing is to minimize the loss in information. So if this information gives almost similar information to this information, then we consider that the system has achieved the aim of dimension reduction. So example of dimension reduction: the transformation of data from a high dimensional space into a low dimensional space is the dimensionality reduction. So low dimensional representation retains some meaningful properties of the original data, ideally close to its intrinsic dimension. So this is actually the main information. Transformation from higher dimension into lower information but retaining meaningful properties. This is the main aim of dimensional reduction. So for example, this is converted to changes axis, and then it is reduced to a single line. Types of machine learning problems. So there are strategy learning. A game is given, but how to win is not known. So we need some kind of strategy. It is requires some strategy to learn that game. You may know that you win on at the end of the game, but you don't know how to win. Your program should learn how to win. This is actually the main purpose of that program. Association is a set of items is given. Your program should find items which appear together. So for example, if a person buy beef chicken milk, another person buy beef cheese, another person buy cheese and boost. So there are some kind of similarities that could be found between the different buying person. So that shows some kind of association between the items or buying items. Strategy learning and association. Association, when we want to discover rules that describe large portion of your data. For example, people that buy X tend to buy Y also. Game playing. Player knows whether it win or lose, but not know how to move at each step. So this is a kind of reinforcement learning in which the player know as it goes in the game. So it learns from the reward or from the punishment. And there is another example of this strategy is a traffic control system in which the system measure the delay of car but not know how to decrease it. So for example, customer 1 buy bread, milk, fruits and wheat. Customer 2 buy bread, milk, rice and butter. And how about customer 3? If a new customer purchases bread, he is likely to purchase milk too. So this is a kind of association. And then a car is coming and it learns from experience to find some space to park their car. So it is an example of reinforcement learning or strategy learning. Types of machine learning methods. So there are 4 major learning methods: supervised learning, semi-supervised learning, unsupervised learning, and reinforcement learning. Actually, the classification, regression, these are example of supervised learning, which require a kind of supervisor. For the system requires some supervisor to learn the available data. So it also requires some label data. Semi-supervised actually classification and clustering are the example of semi-supervised learning. So in which some data is labeled and some are not. Unsupervised learning actually doesn't require any labeled data. So there are some clustering, dimensional reduction, and association are the example of unsupervised learning. And reinforcement learning is actually learning from the environment, from the behavior, from the reward, from the punishment. So strategy learning is an example of reinforcement learning. So reinforcement learning is actually reward is given to your behavior. So behavior is the main thing which earn the reward or earn the punishment. Supervised learning uses a training set to teach models to yield the desired output. So it actually needs some kind of teacher for the learning purpose. Training dataset includes inputs and correct outputs. So it requires inputs, but it also required outputs. So the model is allowed to learn over time that if this input is given, then your output should lies with the boundaries of that output. So this is a kind of supervised learning. Algorithm measures its accuracy through the loss function. So the loss function is more important thing, which reduces the error function. So error between the output function and the output function and the learn or the train function model. So the aim is to adjust the error function until it has sufficiently minimized the error. So for example, this is an example of supervised learning. So to reduce the error. Then this example of classification, dog and cat is classified based on their class. So this dog is actually passed to this neural network, and at the end it decides that it is a dog. And when cat is given that, then it decided that it is not dog or it is a cat. Then semi-supervised learning, a learning problem that involves a small number of labeled examples and a large number of unlabeled examples. So it actually is a mixture of supervised and non-supervised learning. So it required labeled data as well as a large number of unlabeled data. Learning problem these types are challenging. Actually, the learning problem process of this is very difficult. So because of it is neither supervised nor unsupervised learning. Algorithms are able to make effective use of the mixture of labeled and unlabeled data. So for example, this is labeled data and based on that some model is trained, and then there is unlabeled data, and to use the trained model to predict the label for the unlabeled data. So then this data is pseudo labeled data based on the available data, and this is labeled data, previously labeled data, and it retains the model with the pseudo and labeled data set together, and model is trained to get some result. So this is similar supervised learning algorithm example. And then there is some kind of raw data, another example, and a model sample data code and lost new sample data feedback. So some data is lost in this system, but on the based on the available data, the algorithm is able to train and get some product of trained algorithm. So this is an example of semi-supervised learning. Unsupervised learning uses labeled data, so unlabeled data, sorry. So unsupervised learning needs unlabeled data. It discovers, the aim of this learning algorithm is to discover patterns that help in solving clustering or association problem. So if we see that in these emojis there are some kind of pattern, so based on that pattern the emojis are classified. And then there is another example, so some kind of historical data and some live data. So machine learning model is trained, and based on that some anomaly is detected. And then there some raw data, no label, no training data, unknown inputs, interpretation, and then algorithm is applied, process, and output. Based on that the data is classified. Reinforcement learning is actually the training of machine learning models to make a sequence of decisions. The agent learns to achieve a goal in an uncertain, potentially complex environment. And reinforcement learning in artificial intelligence faces a game-like situation. So, for example, this one, a ping pong is played between two ghosts. So this is actually based on reinforcement learning. So these are trained much to achieve this interesting image or interesting model in which a red play with blue. And then there is another system in which this to be passed here based on reinforcement learning. Types of learning methods. So there are three different types of learning method, that is parametric, semi-parametric, and non-parametric. Parametric is actually a global model is used to describe data, so it requires some kind of global model. So the program should estimate the parameters of the global model and answer based on the found model. And then there is a semi-parametric method in which a small number of local models are used to describe data. So instead of a global model, we need some kind of local model to describe the data. The program should estimate the parameters of the local models and answer based on the found models. And non-parametric, these are non-model based approaches. The program should keep all the given data and answer based on them. If a query is given, your program find a small number of clauses, data instances, and answer by combining those. For example, memory-based, case-based, and instance-based learning. Parametric learning methods actually a learning model that summarizes the data with a set of parameters of fixed size and independent of the number of training examples. No matter how much data you throw at a parametric model, it won't change its mind how many parameters it needs. Example of parametric learning methods are logistic regression, linear discriminant analysis or LDA, perceptron, naive Bayesian network, and BCV, and naive Bayes, and simple neural network. Non-parametric learning methods, algorithms that do not make strong assumptions about the form of the mapping function. By not making assumptions, they are free to learn any function from the training data. These kind of learning methods are good when we have a lot of data and no prior knowledge of that data. There are such an example of non-parametric learning methods are K-nearest neighbor, decision tree like cart, C4.5, and support vector machine. Types of learning methods: non-meta or ordinary learning methods to learn given data as ordinary algorithms do. But meta learning methods are those learning methods the aim is to learn how to learn. So it is boosting or inductive transfer are the example of meta learning. Let's see this in a bit detail. Meta learning methods, also known as learning to learn, is a subset of machine learning. It is used to improve the result and performance of a learning algorithm. So if a learning algorithm is not giving much good result, then it needs meta learning method to improve the learning of that algorithm by changing some aspects of the learning algorithm based on experimental result. How we do that? By changing some aspects of the learning algorithm based on experiment result. It helps to understand which algorithm generate best prediction from the data set. So for example, there is input train images and based on that some neural network initial parameters are described, and then some predicted labels are given to the function and train labels and find the loss function, and based on this some gradients are used, and after using the gradient it is passed to an optimizer, and model parameter is also passed to the optimizer, so we get neural network with the updated parameter. So this is an example of meta learning methods. So thank you for watching this video. The value of a college education is not the learning of many facts, but the training of the mind to think. Albert Einstein.